Welcome back to our YouTube channel. Today's topic is balancing chemical equations. So let's get to it. What is a balanced chemical equation? A balanced chemical equation is an equation in which the number of atoms of each element on the reactant side is equal to that of the product side. Okay, now you can recall the law of conservation of mass that you've studied in class 9. That is, mass can neither be created nor destroyed in a chemical reaction. So the total mass of elements on the reactant side should be equal to the total mass of elements on the product side. So let's take a quick look at an example. We have zinc and sulfuric acid on the reactant side, which give rise to zinc sulfate and hydrogen. The equation is written as Zn plus H2SO4, which gives rise to ZnSO4 plus H2. So let's start balancing the equation by writing all the elements and the number of atoms of each element on both the reactant side and the product side. So now let's start off with a simple table which consists of 3 columns, that is the elements, reactants and products. So now this will contain every elements, the number of atoms. So we have zinc, hydrogen, sulfur and oxygen. Now we make a note of the total number of atoms of all the elements on the reactant side and the product side, and hence we get this table. Now from this table we can notice that the number of elements on the reactant side and the product side are equal. So we can say that our reaction is balanced. Now let's take a look at another example. So we have Fe plus H2O, which gives rise to Fe3O4 plus H2. Here Fe3O4 is called as ferroso-ferric oxide, and Fe is ion, and H2O is water and H2 is hydrogen. Now since we know what each and every element means, so let's get to the table as we did in the previous example. So we have the elements, the reactants and the products. So the elements we have are Fe, H and O, that is iron, hydrogen and oxygen. And let's get a count of each of the elements. From the given numbers, we can say that the elements on the reactant side and the product side are not equal. So hence, we need to balance it. So let me start off in a simple way for you guys. We can start off by adding a 3 next to the Fe on the reactant side, as we need not worry about the other elements numbers getting changed. So we get 3 Fe plus H2O, which gives rise to Fe3O4 plus H2. Now we can see that the Fe on both the reactant side and the product side is balanced. Let's see what's next that we can balance. So I see there's oxygen which we can balance, since there's 1 on the reactant side and 4 on the product side. So let's balance it. We can start balancing the oxygen on the reactant side by adding a coefficient 4 to H2O. Since the oxygen atoms in the product side are 4, so we get the equation 3Fe plus 4H2O, which gives rise to Fe3O4 plus H2. Now you can notice that the hydrogen are not balanced here. Since we added a 4 to H2O trying to balance the oxygen atoms on the reactant side and product side, we've now increased the number of hydrogen atoms on the reactant side. So we have 4 H2O on the reactant side and we have only H2 on the product side. That is, totally we have 8 hydrogen atoms on the reactant side and only 2 hydrogen atoms on the product side. So what we can do is add a 4 to the H2 in the product side. So we get 4 into 2 hydrogen atoms on the reactant side and the product side. Now we can see the hydrogen are equal. So is the iron and the oxygen. Hence we can say the equation is balanced. Guys, our equation is balanced. We just have one small but very important thing to do. That is writing the states of the elements, which is very important, where you can lose your marks. So make sure you write it properly. So you have to write the states. The different states are solid, aqueous, gas, liquid, etc. So now here we have to write the states for our equation. So we have Fe, which is solid, H2O, which is gaseous, and Fe3O4, which is solid again, and H2, which is gas. Here, why we're saying H2O is a gas is because it is in the form of moisture or steam which reacts with iron. We get ferroso-ferric oxide, which is a black ore of iron that forms crystals and reacts with hydrogen gas. Well, that's it for today's video, guys. I hope you liked it. And in the next video, I'll be actually solving a few questions from the textbook for your reference. So until then, I hope you liked it. And if you did, drop a like, hit the subscribe button. Don't forget to share. And thanks for watching.